Oh, yes, 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 yes. Welcome, gentlemen. Welcome. We have 4 viewers already ready, including one from the CIA.
Hello, 4 viewers.
What's up, guys? Glad to know you're watching. So tonight, we're going to talk about a little bit about what we have going on. There was a party that was down at the studio there. We didn't make it there. It's 2.5. It's just so far to drive. It's only worth it if I'm going to go down there for like dedicated day of filming and some stuff. So we're going to wait until we have some more stuff together before our next meetup and filming date and the continuation on the Alsa Phan experiment and some other experiments that we're doing in general, just in the general realm of this kind of research to understand anti-gravity and some of the research that has been done by the aerospace companies in the United States over the past 2 decades or 3 decades, because I kind of disagree with the idea that this was developed a long time ago, that it's some low-hanging fruit. I've had some disagreements with other physicists that I've talked to online, including Jack Sarfatti, who says it's kind of a waste of your time to revisit some of these older experiments, and you should really just be focusing on the new stuff 100%. But I really think it's
That's a ridiculous concept. Ridiculous concept. I mean,
it's
so
kind of
many
silly.
great things discovered.
It's important to go over all the old literature, because this is history in the making, and this is what physics students in colleges all across the world are going to be doing in their experimental physics class in 20 years. There are all these experiments going over all the history of this stuff and how it was developed, all the stuff that was classified that's now coming out. And I think it's kind of silly to think that it's not a good idea to do research. The point of research is to go revisit all those old experiments and look at are there anomalies in each one of these? How do you get them? Where do you get them? And why do you get them? And why were those studies classified if they didn't find anything? And why have they been continued to be classified until like just recently? In the past 10 years, it's been like a floodgate of information with all this stuff that's now available, and you can find it. A lot of this stuff wasn't even available in the academic journals. You had to pay for subscriptions to these things to get the publications or really know about this stuff, because it was so on the hush hush. But anyways,
there's a lot of stuff good on IEEE right now, but they are expensive.
I want to introduce my new guest here today. This is someone I've talked to about experiments and stuff on Facebook in the past, and we've collaborated and said we've got to do something together, because this is a guy who runs a channel and does a lot of research on his own and experiments, and is definitely a good addition to our lab and our lab crew that we're trying to build. And I know there's people out there watching, including our CIA staff, hey guys, if you have information, we're trying to set up a way for people to anonymously donate money, funds, anonymously donate research and time. So we're going to be setting up some events here shortly. I want to set up one up in Boston, because I want to start recruiting some of the scientists out of MIT and Harvard, and get people from those schools who are real serious researchers into this stuff, who can help us out. And anyone in basically lab with us, anyone at a university with lab access that can do, or anyone out there. We've already reached out to a couple people, including some people from there's a lot of research that's actually been done around NASA at the Advanced Concepts Research Lab out of Huntsville, Alabama, at the NASA Huntsville, and there's a lot of people at that university that have done some research that we've talked to that have already done some of these more expensive experiments that we're reaching out to kind of, maybe we're going to be able to go there and watch their replications of some of these experiments, and test the kind of things that we're looking for, and really thoroughly analyze their research. and some of the things that they've found. This is all kind of needs to be pulled together, and it's time to be brought out to the public. It's kind of weird. I was just talking, and I don't want to take the stage. I want to let Jeremiah talk about himself a little bit, actually. Um, and let me let you introduce yourself and talk about your channel, man, because you got some real interesting stuff to share. And I'll let you take the floor for a little while.
Okay, cool. That works for me. Yeah, so nice to meet you folks out there. My name is Jeremiah. I have run a YouTube channel called Join the Technicians for a couple of years now. Haven't posted too much recently, so sorry to my subs if you ever see this, but I got far diverted off of the projects that I was posting and heavy into the anti-gravity research. So I've been working on this stuff since I was 13. I'm 33 now, and that's plenty of time, I think, to see some really unique and unusual phenomena. We specialize in really high power applications, particularly fast power and high energy levels. We can virtually evaporate a soda can if need be by a 9,000 joule impulse generator, or generate over 1.5 million volts, again if need be. Our main research here is to create a better power source for anti-gravity research, which has a couple of unique requirements, and included in those is very precise power control for total output energy and very, very fast speeds. Speeds that are crazy high for most engineering principles. Most MOSFETs will not reach the range of these speeds, nor will transistors, but there are ways to get the semiconductors to comply with you if you do so coerce them. But long story short, I have a dream of a flying sky castle, and I intend to stop at absolutely nothing to achieve it. So we've been researching together in this field for quite some time, but not quite so connected as Alien Scientist has brought us all together into this single chat, which is awesome. But basically, that's the intro to me. Yeah. So I'm just doing research on my own in my own home lab.
What was the name of your YouTube channel again?
Join the Technicians.
Join the Technicians. Cool. I'm gonna. Oh, there you are. It's the same as your profile pic. So yeah, you got almost 10K subscribers. That's nice. I'm gonna subscribe.
I don't have any research posted up there about anti-grav yet. I have a whole bunch of video files showing some pretty unique effects that I have yet to post because I can't fully explain them, and the goal of the channel is to educate people on what's going on. So if I can't explain it, I feel unqualified to tell other people what's going on.
That's good stuff, man, because that's kind of what we want to put together with this new show, and we want to basically analyze all this research, all these anomalous effects, kind of nail it down to something, and we're gonna get like expert debunker. I want expert like scientist debunker people like to vet this stuff, to really like go through it, like that, you know what I mean? That's what we're looking for. So I'm putting a flyer together, and actually we're gonna I'm gonna post up around MIT and Harvard and try to recruit some kids
Jeremy, I actually have the perfect guy for the debunker. He actually helped me the other night work out some of the math for the Alsa Phan theory. His name is Tom. Long story short, he bought a battery from me a couple years back, and I realized this guy was a freaking genius. So we started talking about anti-gravity, and he helped me out with some of the concepts of how to do different things with the vacuum tube and whatnot.
Mm-hmm.
And then I actually went and built it. This guy was hired at one point by a multimillionaire down in Florida to go check out some guy that he was funding who was working on those machines that create more energy than you put in. And he went through several of the guy's ideas and actually realized why they were complete and utter bullshit. So he's a very skeptical mind, put it that way.
Right on. So I don't know. I want to like put like I think I want to talk to these media people about putting a show together still and see what they have to offer, because they do some really nice work on the editing side of putting a good piece together that draws people in better than what I'm doing right now currently as far as production. This channel has always been about information and just info dumps, because I just get like all this research that I do and I have a million tabs open and I'm just like, all right guys, this and this, and I go through like everything in an order, and just break down like a ton of shit that half people don't have time for, who even watch this stuff, but maybe they'll take one or two gems out of it and like go and research them, and like it will help give them certain pieces of the puzzle, which I think is awesome. But anyways, the ideas that I think we can draw a consensus on with all three of us is that we want to basically start with the older and more easy experiments to do of the things that are out there. Where the heck is it?
Townsend Brown gravitator. Let's start with that.
Yeah, Townsend Brown gravitator.
Can you put the paper up?
Let's see what oh, I don't want to share your stuff, but
what's a TT Brown
hey,
mercury power generator?
Are you trying to talk? I can barely hear you, Jeremiah. You sound really like quiet and distant. You were talking, so I was quiet, but
Can you hear me now?
I can hear you,
You
Mark.
should be able to hear me very clearly now.
Now I can hear you very clearly. Yes.
Microphone problem.
Yeah.
My apologies. So yeah, I've got a few documents that were research documents done by independent laboratories which test non-asymmetrical capacitors and did still observe gravitational effects from those configurations. They were small. I mean, they're not going to make anything fly anytime soon, but they at least demonstrate the possibility of using electricity to modulate space and time. They talk about the saturation of the external field or the saturation of space, and that does lead to a really interesting question, which is why can you saturate an empty volume of space containing no matter with anything whatsoever? It makes you wonder what space is really made of, and so these documents go into that slightly. Let me see if I can pull them up here, and something else that we can share. But go ahead.
Basically, the Townsend Brown gravitator was a parallel plate capacitor that you charged up to like 70,000 volts, and it moved in correlation to the weight of the dielectric. This was discovered by Townsend Brown. Another theory we had is possibly charging up the capacitor as quickly as possible to see if it creates a warp bubble, which Jeremiah was alluding to earlier. And there's different methods of actually doing that, because we're talking about very high voltages, so you need some way to provide the power. It's really about pulse power. You're taking energy, moving it from point A to point B, and then you're moving it back very slowly. So basically,
let's talk about that. Let's talk about why pulse power is really so important. Besides the obvious, you need lots of power to achieve anything interesting. Pulse power is extremely important because it deals with some other property of magnetic fields that's not normally looked at except for by RF engineers, and that is the radiated magnetic field. You could also call it a radiated electric field, because the truth is that according to Maxwell's original equations, not the four Heaviside modified equations that we're used to seeing, but the original Maxwell equations, which do go into the space-time curl and the various other factors, there's quite a bit of information in that whole topic. So let's get into that a little bit about high voltage capacitors, T.T. Brown's research, and why they work.
I have no idea why they work. What do you think?
So, as far as I've been able to derive from my own research, T.T. Brown exploits a property of magnetic influx in space, which is the transmission of electromagnetic energy. If you take any kind of voltage source, whatever it is, let's say it's a battery, a 12-volt battery, you've got a car battery sitting on your bench, and you suddenly connect a wire to the positive terminal and the negative terminal is grounded. When you connect that wire to the positive terminal, all the voltage available from the battery, even though it's small, is going to instantaneously start to travel down that wire. Now, it's not going to reach the end in a split second, but that potential voltage will, in fact, travel down that wire. And by the time it reaches the end, something kind of unique happens. That wire happens to have a capacitance to all of its surrounding materials. So that's the ground, that's your lab equipment, whatever. That single piece of wire just sitting there on your floor or on your bench, you connect it to a voltage. By the time the voltage reaches the end of that wire, it has gained significant potential. The reason why is electrons don't really move all that far down the wire. They make a small jitter forward, and that jitter gets conveyed to all electrons down that wire within the constraints of the inductor to the point that it reaches the end. And because the momentum is carried from each electron to the next, what ends up happening is you have some electrons that don't really move at all. And you have other electrons which have an incredibly high momentum or a very large amount of stored potential energy that they are just waiting to exhaust. So with impulse systems, we utilize this phenomena in trying to create very, very powerful pulses where we allow the electrons to naturally accelerate, a small number of them, I should say, a small number of electrons accelerate very, very quickly, and those electrons contain most of the momentum from the total dissipated energy. If you put power into a system, that power has to go somewhere. If that power doesn't come out as heat and it doesn't come back out as electricity, it's radiated out into the environment. So back to T.T. Brown. T.T. Brown discovered that if you radiate a certain percentage of the total energy, let's say that you have a sine wave, it's 50% positive, 50% negative. If you radiate the 50% positive energy via very fast impulse, let's say you put 50 joules into the system, for example. Let's say you radiate 40 joules. When you come back to ground or baseline, when your waveform reaches its zero crossing, your energy, you're only going to have 10 joules left because you've just expended 40 of it transmitting those electron momentums into the atmosphere, which can be picked up by other electrons. The rest of the 10% now shifts the baseline. So you can create this asymmetry of charge in the system where you have more power being dissipated on the positive side than a negative side. And so the negative side of the curve can get returned to the loop, and you can use that if you so choose. But ultimately what you're concerned about is how much power you're transmitting outwardly. And that's the key to the whole T.T. Brown stuff. The power that's within the dielectric for his capacitor is the dielectric between the big parabolic reflector in his earlier patents and the positive small electrode on the bottom of the dielectric. So those materials depend very, very heavily on a fast impulse, and the amount of material present at each electrode is going to have a huge influence. If you have a very large number of molecules that can flip around their valence bands to create a reorientation of the electric field that's currently existing within that dielectric, and you have a very small area where you can get significantly higher energy, then you have to deal with the fact that as these valence bands flip, you provide potential across the capacitor, these valence bands flip, that energy that causes them to flip is going to be radiated outwards, and it's not just going to affect the material that it's connected to, it's also going to affect the external space. This creates a much wider field, which has, like I mentioned earlier, some unique and interesting properties, and one of them is the speed of light slightly shifts just ever so slightly, and we can show this with some other experiments, and this is again why we're doing this cast, because we need some equipment in order to be able to test these effects. So one experiment that's been postulated, and one that I've done on a small scale but need some significant resources to continue on here, is a laser experiment which demonstrates the slight shift in wavelength of a laser. In order to do this, we'd need a wavelength meter and a couple other pieces of equipment, but ultimately we can demonstrate through magnetic saturation of three-dimensional space, we can actually shift the wavelength of a laser beam just by a tiny, tiny percentage, which is nothing more than a proof of concept, but at least it proves the concept.
That you're creating a warp field.
Yeah.
That's correct.
We also need an op amp, and and a lock-in amplifier would be great. You know, some other things to add to the whole lab list of equipment.
My theory on the Townsend Brown gravitator was that it was a take on Podkletnov's experiment. Podkletnov, what he discovered was that if you impulse a superconductor, there was a pulse that was created past the superconductor that continued on for pretty much infinity, as far as he can tell.
So,
and the most interesting parts about Podkletnov's experiments is that he claims he had measured speed significantly faster than the velocity of c, or the speed of light.
Speed of light, and not only that, but he discovered that the power of the impulse, as you doubled it, the impulse would go up by 10% times 10. So it was like a hockey puck. It wasn't a equal distribution, meaning every time you doubled the voltage or doubled the amount of joules going in, the impulse would be going up by 10 times. So therefore, it's theoretically possible to create a sort of sawtooth wave with a very sharp rise time and a very slow drop time. And if you create that along a big enough capacitor, moving enough joules around, you'd actually be able to propel the craft through space-time.
So let's talk a little bit about Podkletnov's experiment and what he did. So he has a disk of superconductor material, and I don't remember the exact dimensions. Not so important. Anyways, he rotates this.
Very important, according to him. No, the dimensions are important. It needs to be big.
Oh, you're absolutely right. It needs to be big, but the exact dimensions aren't important. The size, however, is, because the effect is exponential.
Because it was 9 centimeters, and then he built a couple larger ones. But they activated at different frequencies.
So what he does is effectively have this material already supercooled. So it's in superconductive state. He then strikes it with the output of a Marx generator, which is a particularly interesting device because it produces an extremely fast impulse, which means holy boatloads of current. We're talking tens of thousands of amps instantaneously available at potentially, tens of thousands of volts. So he would discharge this Marx generator directly onto the surface of the disk, which was already rotating, and this disk was existing within a magnetic field. When the high impulse electrostatic field hit the disk, a current was conveyed around the periphery of the disk, and because, as we know, the superconductors don't lose any energy, as the electrons from the discharge are diverted because of the impulse, and they flow freely without any resistance through the superconductor, he noticed a really unusual effect where there was either an attraction or a repulsion from the source disk. So there's a couple things going on here. First off, you have your rotation speed. You have to have a source that is already in motion, because that motion slightly shifts the relativistic mass of that material. When you accelerate anything, whether it be you on a bicycle or in a car or a bullet, it doesn't really matter. That material, when it's traveling past you at high speeds, has a slightly higher relativistic mass, and that mass equates to a stronger momentum when it makes its impact. We call this effect inertia. Podkletnov discovered that you can convert inertia from a motion of a large number of electrons through an electrical discharge onto a superconductor. And when the motion of all the electrons strikes the superconductor, they're converted into a magnetic flux, because they have to flow through this material that has basically zero resistance. So they have to divert their path.
The magnetic fields can't flow through the superconductor. They're all expelled.
Right, but the electrons still have to interact with the magnetic field of the superconductor. So, So when they do this, they move very, very quickly, almost at velocity c, through this material, and in doing so, a very large number of electrons from an electrical discharge, thanks to his Marx generator, travels through the superconductor, and it travels so uniformly and so quickly that it creates a very specific magnetic impulse. And this magnetic impulse can affect other materials that are outside the immediate proximity of the superconductor. And he was able to, according to his claims, have several floors above him in the building that he was operating in affected by this flux. And in later experiments, he claims also that due to high impulse currents, he was able to shift a very large amount of mass at a distance, several kilometers distance, from its original position, effectively exerting a force on a needle point-like or a very narrow beam from this device and break right through solid cement walls, metal, just about anything, because those molecules in those materials were physically diverted from their original position to a new position due to the strength of the electrostatic field that hit it. But we can quantify this down even simpler. Podkletnov's device uses one simple principle above and beyond all else, and that is the extremely high impulse electrostatic field. It's not magnetic per se. The magnetic flux that's generated by the superconductor when a high voltage source strikes it and a very large number of electrons flow through it, it does create a magnetic field, but that's not really what we're looking at. We're looking at the magnetic flux that it generates, and that flux is at a high enough amplitude where the voltage, where the volts per meter are capable of generating more than enough power to burn up small wires or just about anything like that. It's all about the volts per meter, the very fast motion of electrons over any given space.
Podkletnov claimed that the impulse was gravitic in nature because objects would move in relation to their weight. So, like an object that weighed 5 pounds versus an object that weighed 100 pounds would still move the same amount, and their impulses would be in correlation to their weight. And this was true for even non-ferrous and non-electrically conductive materials. He was able to break through a brick of concrete with an extremely 3 million volt impulse from the Marx generator. So he claimed that there was a connection between the electromagnetic pulse created and a gravitic impulse. And this is something
that does make sense.
And this is something that Tesla discovered as well with high voltage electric impulses. He felt them across his body, and he postulated that there must be an ether that is allowing this energy to travel, allowing this gravitic wave to travel. And it also makes sense that this is what's going on in the base of the ARV. I don't know if you're familiar with the ARV, the Alien Reproduction Vehicle.
Yeah, there's a large capacitor bank, and it's specifically oriented where each plate is staggered exactly at 90 degrees or halfway through the next plate. So you have a layer of, say, 14, 16, 20, doesn't really matter the number, plates, and then immediately underneath that you have another layer of plates where the center of the plate beneath it is exactly at the in-between point of the two plates above it. This does create some very unique magnetic fields. So it's all about the entangling of those magnetic fields and how much you can saturate that local space around the capacitor, the discharge capacitor, with strong fluxes. We'll get into the ARV, I think, in future videos, though, because we can talk in detail about the design of the coils and the resonance circuit.
Okay, I mean, my experimentation at the moment is concentrated on the gravitator and also the Alsa Phan theory. The gravitator, we got to building a parallel plate capacitor and charging it up. Unfortunately, right now, the voltage is leaking through, and we're getting arc over around the side. So we probably have to enlarge the parallel plate capacitor with more layers of glass in order to increase its dielectric strength. So far, we have seen movement with the gravitator, but the problem is we've then found out later that it was really electrostatic repulsion, which is always a problem when you're dealing with high voltages. We're in the center of a room-sized Faraday cage for protection, so you got to make sure that the test subject is smack in the middle, otherwise it will interact with the ground walls of the Faraday cage, proportionally to whichever one it's closer to. And after removing all of those fields, we found we tried a smoke stick experiment to make sure there was no ion wind going on, because ion wind is well understood. It's not anti-gravity. we didn't find much ion wind going on, but there is the arc over problem. And then at that point, we're not seeing any movement. We're not seeing any ion wind. We're not seeing any movement, but we are not reaching the critical voltage of 70,000 volts without arc over. So we need to add another layer to see whether that that experiment does actually work.
Okay, so imagine this. Imagine. Sorry. Yeah, go ahead.
Oh, so basically that's the next for the gravitator experiment. And then after that, we'll work on trying to do impulses at around 70,000 volts. It might be easier just to use a Marx generator at this point, but that'll have to take the experiment outside because I don't want a Marx generator with a million volts in the building. It wouldn't work right.
I got you covered on that front. When it comes to high voltage, no problem at all. I will definitely help you develop or build equipment and send it to you.
Oh, that's amazing. We would love that. Right
so
now,
go ahead. Let's get a chime in from Alien Scientist here.
Yeah, so I'm just reading comments and stuff and handling pictures in the background and stuff. So
it's been a crazy week for Falcon Space. We actually met up with two different teams, Jeremiah and this other team down in Huntsville who's working on anti-gravity. It's great to know that we're not the only ones out there. And again, our belief is that
there's more people. Dude, I honestly, I've been saying that for like a couple of years now that there's a Manhattan project kind of going on, but it's not like, it's so secret that I don't even think Trump knows about it because he hasn't said really a peep about like, he seems like completely uninformed and out of the loop of all this stuff. Like he thinks that, you know, he hasn't said anything about it. So I almost think
let's
like.
Let's not forget what happened to JFK when he decided that he wanted to go public and decided to inform his peers. Very, very bad ending.
Yes, right. The difference between us and JFK is that JFK didn't tell anybody that he planned on doing that, and it didn't become.
And we're telling everybody everything.
We're telling everybody everything. We're open source. If Jeremy were to go missing one day, it would be extremely suspicious.
Yes, it would, but more so than that, if he were to go missing one day, everything he pretty much knows is already out there, so you're not going to really have much of an impact.
Right. No, you're not going to do
have
anything.
The opposite impact that you want. The opposite impact.
It would.
People are just going to have their theories proven, and that's it. Then everybody knows what's going on, so that's not to mess with the scientist.
Ning Li disappeared working on Eugene Podkletnov's experiment.
I have noticed a trend of anybody who tries to heavily protect their information and is really, really squirrely about releasing anything, they tend to disappear. So, quite frankly, if you want to stay around, make sure that everybody else around you knows everything that you know, and you don't have anything to be eliminated.
That's kind of like what we're trying to put forward to is that like people should come out and join this kind of thing too. Like there's lots of sources to get the information out there simultaneously if you do want to go public and bring this information out. Like don't just bring it to me and drop it at my doorstep. Like send it to like everybody. Send it to like everyone. And I mean by everyone I mean anyone in this community who means anything. I don't know, like it's crazy because I've shared so much stuff with some of these other people in the community out there, researchers in UFOs, and no one's into like specifically this stuff. There's very few people that are into like just the anti-gravity research and the technology alone.
I'll definitely second that, man. That's a fact.
And
people are really just not interested in investing the sheer amount of time and energy that it takes into getting down.
They're all talking about UFOs and these lights in the sky and like pushing for disclosure and like ask this questions of your senators. Like they're gonna ask, they're gonna end up asking questions that are gonna make them look silly, and they're the wrong questions to ask because at the end of the day, what matters is the technology, and I've been stressing this for years, and I've been like almost trying to focus exclusively on this for the past 2 or 3 years now at least, and pushing people towards that, and who get into this field, because this is like where you should end up if you don't end up too like way deep down some dark rabbit hole of whatever belief and whatever you're following. This is the way. And it's not going to be a low-hanging fruit. It's not like, I don't think anyone in the government really knows all this stuff either, because like even our best physicists out there like are just starting to understand this, and it's really like it has to be a consciousness and a community effort for us as a species to really like make this leap if we're ready for it. And
I agree that it has to be a community effort. I don't necessarily agree that nobody knows about it, but I do think that there's a very strong push for people not to talk about what they do know.
Yeah,
there's definitely a plentiful number of people who know.
Well, there's also a stigma around it that, like, all the technology would allow if it fell into the wrong hands and stuff, and I think that's important to understand too, because it's like, yeah, although like a guy like, although it really, I don't know, it would be hard to say, because it's like there's ways around it already. We've already like released the quantum radar stuff, so even if you're using like warp or stealth invisibility cloaking, there's still ways to detect you. And
it seems awfully a big shame that we already have technology to detect this stuff before it even exists out in the public.
Right, but yeah, it's nobody like I'm just crazy that like on all the mainstream channels and stuff, this isn't not like we're the only ones doing this and talking about it and stuff right now, and I want that to change, because it needs to be like I see a lot of change, and I see a lot of people are already promoting all the good that's been caused by the TTSA getting some of this information out in the mainstream media. And I agree that like, yeah, that it's opened up conversation about it, but like how really has it changed the mainstream scientific and academic community's view on the subject, and like
not at all.
And
they're
it's
not really much.
It's not at all, because they haven't like come out with the real goods and like set it up for peer review and analysis. They're just teasing it. They're teasing it all out, and like and just dangling this carrot that's always like a step away, and like and then they like we're promoting this whole big announcement, like we're gonna release it again. They keep like promoting like they're gonna release the big thing, like this big announcement and this big release, and then like they did it again, and then it was something about a toilet that they invented a space toilet.
Congratulations to them. Wow,
that was on Twitter,
dude. Really bad.
That was on Twitter, dude. Did you see that?
Yeah, exactly.
Oh my god, like that's why I love Twitter. It was like classy. I was like, this is great, dude. Like I shared that. I was like, the space toilet, where the heck is it, dude? Did they take it down? They must have taken it down, dude, because I just everybody ripped them for that.
They needed the extra a-hole for the toilet.
It's gone. Yeah, it's gone. I don't know where it went. I think I took a picture of it, because I thought it was so funny. I took a picture of it and posted it to Facebook as well. Let me see if I can find the picture of that. Hold on a second. Oh, what the fuck is that? That was funny, dude. The space toilet. Oh my god, TTSA. Oh yeah, here it is. Hold up, I'll bring it up. I gotta bring it up. This is confusing. Alright, so I don't know what happened to this tweet. Let's see if you can find this. It was on September 28th on To the Stars. To the Stars Incorporated. And it was they've invented a new anti-gravity toilet. So it was this big thing on anti-gravity that they were going to release, and it was an anti-gravity toilet that has no need for water or plumbing. It's revolutionizing pooping in space. I don't know. It seems like, come on, guys. Like, what the heck? It's like another turd. No.
I just think about the sheer amount of money that has been spent on an anti-gravity toilet and thinking what we could do with that.
Well, I'm just thinking of all the money that's been spent on all these black programs that have been going on. Like, you know, the 2.3 trillion that went missing from the Pentagon before 9/11, and I know like it went to like fund the war in Afghanistan that was already being planned and set up to go there for all the minerals, because they have the like one of the largest supply of lithium in the world,
And of course, they've got the ultimate bane. They've got plenty of oil.
and the whole golden triangle with the opium trade and everything that was going on. But
That is definitely a thing. I wish I sort of in some way didn't know about it, but my cousin happened to be deployed out there, and he observed some pretty disturbing things. And one of the biggest ones was the opium trade, but second to that is the clear and undiscerning battle for oil. We need, as Americans in this country, tons and tons and tons of oil, and people have no idea where it goes, where it comes from, or how it's used. And for some reason, people seem to be convinced that this is the ultimate energy solution, and all we have to do is continue pulling old dead tree matter out of the ground, but it's not going to get us where we need to go. We need better technology.
Dinosaur juice.
It really is. Well, not just dinosaur juice, but also mostly it's dead biological matter. It's primarily plants, trees, stuff like that. And we are already using this technology to generate other types of oils. For example, corn crops and ethanol. Huge deal right now. Tons of farmers all across the United States farming corn for nothing other than the purpose of generating fuel. But ultimately, you're not gonna. You can't burn something and rely on the power of the sun in order to get yourself to Mars. You need something that's a little more reliable, something better, something more powerful, something more localized, and there are plenty of options out there. They're just not in the mainstream right now, which is a real shame.
I think the way we should power the craft is using the powertrain of the Toyota Mirai, that hydrogen fuel cell powered car with a high battery backup. I think that will provide a sufficient power supply for this craft, and then you can just add more tanks, you know, if you want to go on a farther trip.
But I also want to know what you guys think of all the, you know, this is a good place to start, because this is going to get us all the lab equipment, and it's going to test all the older theories to see if like this new stuff is just unobtainium and a dangling like fruit. That's like, because they keep talking about this this stuff's making the news, and those exotic materials.
Yeah, but where are you going to get the exotic materials from? Like, which material scientists do you know that can provide that for you?
Well, I know a couple people that might be able to build some cool stuff, and you know, we're already going to build some kind of nanomaterials for this Alsa Phan experiment to complete that, just to test these ideas. But it could be related. I think it's interesting that some of this stuff, you know, the classified stuff tends to not get talked about and get swept under the rug and disappear. And that's exactly what happened with this video recently. I'll post a link to it in the description if anyone can find a copy of it. But this video disappeared, and it was one about it was one that Hal Puthoff gave at the was it the Scientific Disclosure conference? No, not the disclosure part. Did he? This is it. The Joint Conference for the Society of Scientific Exploration and the International Remote Viewing Association. So,
Jeremy, you got to be copying these YouTube videos down and have them in hard copies.
I know. I know, like the good stuff tends to disappear. So when I see stuff like this, I gotta record it and do like screen records and grab it, you know. And I've been doing some of that stuff too. Yeah, I gotta grab that. This is one you can get, but you have to buy it for $10 from Vimeo. Apparently they got it, and this was it. This was definitely the conference I'm talking about. He talked a little bit about the Tic Tac, but that wasn't even the interesting stuff. The interesting stuff was some of those papers that he talked about and that he showed, and we had one of those papers at that conference, and that one disappeared off the table. it was one of the only papers that we had that just disappeared, and then like I don't know where the copies of it that I had on hard copy went. I have to go. I have backups and stuff that I have to go through and really look and find and see if I have a backup copy of this paper. But he presented it at one point in this thing, and it was that whole paper about that metamaterial that they built that had the it was just a super fine a layer of a mirror and then a dielectric and then a mirror on top of it, like a ultra capacitor, but ultra thin, like super thin, but like super wide and super long. So like basically the whole idea is that if you had the hull of a craft, it would be like this type of material at the very edge of the surface, and that like by reflecting the light barriers between these mirrors, they can get it bouncing back and forth, and then they excite it to the point where it gets so strong that it creates these polaritons. And the polaritons are basically like that polarization of the vacuum energy, which breaks the quantum entanglement information loops and breaks the information of inertial mass, so that information can't be communicated outside of the bubble. Kind of like it. That's the whole idea behind it. But I think there might be more to it, because like you guys were saying with these fields and stuff, and that's what Jack Sarfatti seems to think, that it needs a quantum computer to really understand like the information flow of how it needs to warp itself through space-time and compute that, because it basically needs to create this reflection of space-time around it, and then move that in this simulated bubble in order to move through space-time itself.
Where I would agree with you that quantum computers would be quantum computers would be nice to log all these effects, I would have to disagree in saying that they're necessary, because we have to look back into 1950s and realize that these scientists were already screwing with the effects. T.T. Brown, for example, and they were well beyond the point of quantum computers. I mean, these come way before that type of technological advancement. And ultimately, these guys are experimenting in the lab, and they're screwing with the stuff.
I don't agree with all of Jack's the stuff that Jack says, and I really want, like he seems so hard set on his ideas, but I'm like, well, do you have a working craft then, and this is how it works? You're sure of it? And the answer is no, because he and I don't know why he's discouraging us from doing these experiments, but it seems like a great place to start. It makes a great place to start. It seems like a great place to start. And I asked him if he'd, because he's one of the few guys that are out there talking about this stuff at a level where like they really understand it and stuff. And I was like, hey, would you like to, be interviewed and be part of the, I'd love to talk to you and like interview you and get your spiel on this, because all you seem to do is these interviews on the Star Drive report, and it seems like this guy's like your lapdog, and you basically just feed him all the questions that you want him to ask you ahead of time, and you have all your answers pre-scripted, and then you just.
I hear you. At the end of the day, ultimately, they're not providing engineerable information. We're not going to go, after listening to these interviews, back into our labs and perform experiments because there simply wasn't enough data provided. There's a huge amount of concealment going on, which is really unfortunate.
Right, and I don't know. I would like more information out of this than the stuff he keeps posting over and over again and saying, this is the goods. Because if it's the goods, then well,
we should be able to build it.
We'll see. Have you seen the stuff that he keeps posting? Let me see if I can find.
I'm not familiar with all of his materials, but I'm familiar with a great number of them. I will definitely take a side seat here to see what you have.
Let me see if I can find this one video. It's a shortened clip that's on this channel, I believe. Yeah, this is it. This is. He keeps reposting this little excerpt, and it's this little part with this talks about this glass substrate and then all these layered of these nanomaterials with different 10 nanometers, 22 nanometers, 9 nanometers. This is similar to what I was talking about. I've been talking about this for 10 years. What I referred to as there were topological insulators and layered photonic band gap materials for separating off the different band gaps of frequencies. But these kind of work in a little bit different way. I was unsure of all the physics involved back then when I first started learning about this stuff. But this is all Hal Puthoff's been involved in this research, and a lot of the guys that he's written papers with and done stuff with are very interesting. But it just makes me curious as what they're doing, because they're not really pushing disclosure, if they're scientific disclosure, if they're not like really pushing this information full force, and they're instead pushing this Tic Tac video, which is going to get debunked. And these materials, they're alleging that they have materials from a UFO, right? And I bet you anything, right? That's what they're claiming now. It's been on Fox News.
Is this recent?
It was recent, yeah. Where was this?
This I haven't heard about yet, so this is news to me.
Yeah, this was kind of recent. I just, I don't know if this was it. Yeah,
well, it would make sense. To the Stars Academy is not really about open source anti-gravity. You want open source anti-gravity, go to Falcon Space.
Well, that's what we're trying to start. Is like I've been saying it from the start, like that they talked about this scientific like division, but then they had an entertainment division, and I said this is going to be all entertainment, and there's going to be very little science that comes out of this, or that they're allowed to talk about or release any of it if they are. It just seems too mainstream to be. Everything that's mainstream like this is always controlled, and bullshit. Like you have to understand that. Like nothing gets this big and gets off the ground like this. Like. The real stuff gets like very little views and gets swept under the rug and like leaks out. It's weird how it works. So anyways, UFO investigations expert. This was published 1 day ago. This was yesterday. I saw this and it was on Fox News by Charles Crates. I don't know this guy, but UFO investigations expert claims group could have physical evidence to make some sort of definitive conclusion. So look at this. This is like already setting it up. It's already setting it up with the language and foreshadowing it. You know what I mean? And it really just seems like they're going to claim that they have this metamaterial and that it works on UFOs and stuff. But then it's all going to be debunked and like thrown in the garbage on purpose so that people like think that this stuff's hogwash. And I don't know. It's like, I don't know. That's kind of what I see going on. It's weird. Did you see Mick West has been the top debunker guy. He's been talking about Steve Justice. They've been having this whole here his tweet. Steve Justice appears to have some deluded idea that the TTSA's science division is going to figure out how warp drives work, and then he's going to build one. He's either seriously misunderstanding reality or he's got suckered in somehow. That was his.
It does kind of sound like that to me too.
But yeah, it's I don't know. It's like I just see this is going to be them like parading this fake tech out there. The way they can strawman it, and debunk it, and then like I don't know, and then hide the real
until
shit.
Until people start getting busy in their labs and trying stuff that hasn't been tried so well. Until I stop looking at the textbooks and really going to delve deep into previous history of what other scientists throughout our modern era have discovered, they're not going to get there.
Right.
Because the fact of the matter is, many of the equations that explain what's going on here are not contained within your standard physics model. They're very, very old physics models. They're so
antiquated.
far out of date that they don't work. They just don't work.
Part of the cover-up is in our schooling, and going to school and having a physics background could actually put you at a disadvantage when it comes to anti-gravity, because we're misled in our universities.
Well, that's why I never wanted to go to grad school.
We're our current dogma of science. Science in many ways is a cult. You know, there's people that are holding certain theories so strongly that they'll fight you, you know, even if it doesn't make any sense. And
there's a new age of physics that's going to emerge from this, and I've been saying it since I launched that Hubbard Brothers initiative. It's the age of entanglement, and we're reached that now, and it's crazy what's going on right now, because we're reshaping all our views of what is EPR, Einstein's relativity, general relativity, and the Einstein-Rosen bridges and entanglement, and how the universe is, how space-time is weaved and put together. And I think that's a big key to the heart of it. And
Bart Bircher just asked in the comments if we seen Alsa Phan. Yeah, we're working on Alsa Phan. Actually, we're having some trouble creating a laminar magnetic field, which is required. So that's our next project. Jeremiah is going to help us out with that. The sample,
yeah, most definitely.
The aluminum, iron, cadmium sample is going to be made in a furnace. We need to figure out where that's made. But the signal generator and the amplifier and all that stuff is ready. And we also have a force meter to see if there's any difference in the weight of the object. And we plan on going forward with that experiment. I think that would be very interesting.
It has been far too long since anybody attempted to duplicate some of the well-published results of Alsa Phan. He's got some really good information in there, and it's quite frankly just begging for somebody to stick it in the lab and test the stuff. So I'm glad that we're on board already with this.
There may be more than one way to produce anti-gravity. Anti-gravity is a pretty broad concept too, because you could shield the mass of the craft and make it float. You know, is that anti-gravity? You can create a warp field. Is that anti-gravity? And according to Bob Lazar, you can make gravity off phase. I don't know if that's bullshit or not. It doesn't sound very legit to me. But I'm
not sure what he means by off phase. I don't believe I've seen this Lazar interview that talks about off phase power.
The gravity B wave and the gravity A wave. You never seen that?
Yeah. There is definitely something to it. That's something that we've observed. We've noticed attractions. For example, I did a really simple experiment, just super simple. I took a piece of aluminum tape, highly conductive material, self-adhesive, 2 inches by 3 inches. I stuck it on the back of a piece of fiberglass printed circuit board material. This is just a non-copper coated material that was plain fiberglass pressed into a thin, 1 millimeter thick material. So we stuck a plate on one side. On the other side, there was nothing. We noticed that small lightweight objects that were placed directly on the surface of this insulating material, this printed circuit board material, would experience attraction, and we could pick up foam beads or other small lightweight objects by applying a 50 kilovolts, or a 50 kilohertz, 10 kilovolt signal, which is not a tremendously high amount. I mean, that's your basic standard TV flyback signal minus the DC rectification. But so you take out the rectifiers, you stick a flyback transformer directly on a metal plate on one side of a printed circuit board, the other side has nothing. If you stick small lightweight objects there, you'll notice that they're attracted to the high frequency electromagnetic field. And the reason for this is pretty simple. The magnetism doesn't play too much of a part in this, but the electrostatic field attraction does. When you have a plate on one side of a printed circuit board, you have voltage that you're going to apply to it. So in this case, we're applying, many tens of kilovolts at a very high frequency. That material causes anything else on the opposite side where there is no metal plate to be attracted, because capacitance dictates that when you create a strong positive charge or a negative charge at any given point in space, that everything around it will have to be polarized. So a material that's neutrally polarized, say it's a ground potential, a foam bead, for example, when it comes into the proximity of this field and it goes extremely positive, some amount of electrons will be pulled off of the surface of that material, and they will transition into the electric circuit. When you invert your polarity, some amount of electrons will be deposited back into that material, and your circuit once again inverts. But here's the thing. With inverting polarity, you have an attraction because you have a positive on one point, which is your power source. You're providing, say, during the positive side of the cycle, a very high 50 kilovolt signal electrostatically to this metal plate that's on the back side of one piece of printed circuit board material. On the opposite side, you have 0 volts starting out. You have ground potential. Any material that's sitting there has also ground potential, but the printed circuit board material is made of an epoxy and fiberglass, and both glass and epoxy have a very strong dielectric strength. So as the charges begin to migrate within those materials and the orientation of the valence bands flip, any material on the opposite side of that insulator is going to eventually receive the magnetic and electric field from the charged plate that you're providing power to. And those materials will be at ground potential where your source is going to be at 50 kilovolts or whatever potential on your metallized plate. Those things are now at different potentials, so you take into account 50 kilovolts difference between object A, which is your foam ball or whatever, and object B, which is your metallized plate and your dielectric. 50,000 volts is quite a bit of force. I mean, when you rub your head on a balloon, you're talking maybe 5 to 10 kilovolts, and that thing can stick itself onto a wall for hours on end. Now imagine you amplify that same effect where the balloon sticks to the wall, but you do that same effect, all the force that's concentrated in the balloon sticking to the wall, you trigger that same force 10,000 times a second. Well, now you've got something really tangible that you can work with. So ultimately, it comes down to the fact that an object starts out at 0 volts. You provide a high voltage source that's near that object, and that object will eventually pick up some ions or electric field potential from that source. And when you discharge it, the source is already charged to the same field potential as your source or some percentage of it. When you invert that polarity, now that field source is at the opposite polarity that it started with, and your other object, your foam ball, is already charged in the opposite polarity, so they're going to attract to each other. You can also phase this thing to cause them to repel to each other, which is your simple electrostatics. But as you increase the introduction of alternating current fields, you can significantly increase the effects. So this is one of those strange things about asymmetry, where if you continue, let's just say you had 2 charged spheres. Break this down. You have a charged sphere 2 inches in diameter, and you have another charged sphere sitting away from that 2-inch diameter sphere by 2 inches, and it's another 2-inch sphere. So now you have a sphere, 2-inch gap, and another sphere. You charge one sphere up to 50,000 volts and the other one sitting at ground potential. These 2 spheres are going to have a significant attraction to each other. If you discharge then the charged sphere, they're obviously not going to have any attraction to each other. Now, if you continuously keep the first sphere at 0 ground potential and you charge the second sphere at 50,000 volts and the negative 50,000 volts, it's going to have a continuous attraction to the first sphere because it's always at a different electrostatic potential. And as we know, when you have a lack of electrons in one area and an excess of electrons in the other area, you're going to have an attraction for the electrons that are in excess to try to move to the area where they're more balanced, which is in the place of a lack of electrons, because you've taken them from one capacitor plate to the other. Just like your parallel capacitor plate experiment, you're going to notice that you're transitioning electrons from one spot to the other. If you can do that fast enough, you can create a continuous attraction force. Now, if you have electrons already in your sample and you provide a negative electric charge, those electrons are going to be repelled away. So as electrostatic force designates, you will have a significant force away from the source charge. If you do this fast enough, say 50,000 times a second, 100,000 times a second, you invert your charge, you're going to end up with a net attraction. And if you can synchronize the charge on your source, where every time your source is negative, your sample is negative, you can create a repulsion. So by using phasing with your AC signal, you can create repulsion or attraction in any fashion, and gravity is not that much different. So if we take a look at an electron around the valence bands of an atom, that electron is rotating extraordinarily fast. If you take a look at its motion, it's moving nearly the velocity of the speed of light. That means the electron may have a slightly different mass than it would at rest, which we already know electron can't necessarily rest, because so far in 2019 we have yet to see a single experiment that designates the absolute mass of a single electron. We don't know. I mean, as a human species in 2019, we literally don't know how much an electron or a proton or a neutron weighs. The neutron is our most accurate measurement because its magnetic flux is continuously switching. But as far as a proton and electron goes, we don't really have a lot of information about how much they weigh. We make some estimates. We know the proton is smaller than the electron, but by a very rough estimate, which has a pretty high percentage of inaccuracy, ultimately,
Sorry,
all of these effects that we
mean
see are gravity.
Electron's smaller than the proton, right?
Oh, the electron is much larger than the proton, about 2 times.
Just to clarify, do you think the source of gravity has to do with the electron field around the atom?
It absolutely 100% does. This is something that's been tested and tested again. There's no reason that I should be able to take a flyback transformer with no rectification, AC output at 50 kilovolts, and pick up small objects with a capacitive field if it had nothing to do with gravity. And if you just simply take that same logic train and say, okay, I'm only at 50 kilohertz, but gravity is potentially the nature of one single electron orbiting around one single valence band of one single atom, and you were to say this electron, because it's in motion according to Maxwell's equations, anytime it moves through three-dimensional space, it must create a magnetic field. Well, the electron has a fixed electric field, so it's not going away. As the electron moves through space around the orbital band of an atom, it has to, according to Maxwell's equations, produce a magnetic flux. When the magnetic flux is created, that is dissipated energy. So what we discover is that every single atom in every single molecule in existence does in fact create a continuous radiated magnetic flux. And because that flux is radiated, meaning it doesn't stay within the constraints of the individual atom we're talking about, but it travels outwards into 3 dimensions of space in all directions to infinity, this magnetic flux is lost from the system. So if you were to take a single molecule, or excuse me, a single atom, let's just say you take one hydrogen. That one hydrogen has a proton and an electron. The electron is rotating around at a very high speed, nearly the speed of light. As the electron moves through 3-dimensional space, it is transmitting an electric flux because of its change in position, and that magnetic flux translates directly into, according to Maxwell's equations, a dissipated amount of energy. So you could say every single piece of matter in all of the universe, which has at least one proton and one electron, because the electron is rotating around the proton, generates an outflow of energy which is never recovered. The fact that it is losing energy due to generating magnetic flux means that the energy is asymmetrical. So where the mass is, you have a strong electric flux generated by the charge of the electron or the proton. You also have a strong magnetic flux generated almost exclusively by the charge of the electron rotating around the proton, because the proton doesn't move.
What about a neutron star? How does that have gravity? If it's all coming from the electron, how does a neutron star have any attraction?
A neutron star has an incredibly fast oscillating electromagnetic field, or electrostatic field if you really want to get specific, that is rapidly changing. And those factors where you have a fast changing electrostatic field combined with a very high amplitude create a attraction, and you can call that attraction gravity. In fact, if you wanted to quantify gravity down to something much simpler, you can just say gravity is the result of the electric charges of all matter as they interact with each other, and the fact that an electron rotating around a proton is dissipating energy continuously. I mean, it's actually transmitting. It's like you have a little tiny, nano, I guess picowatt transmitter that is continuously sending out energy. That energy
is very interesting what you're saying, because we were studying the other night with Tom in the lab. We're trying to get all the math right for the Alsa Phan experiment, and we're trying to figure out the Lamore frequency of aluminum. And basically, the Lamore frequency of aluminum at the Gauss that we're talking about, because it's all in relationship to the strength of the magnetic field, is in the megahertz range. And in the experiment, they talked about, being in the gigahertz range was the field that they put out. Then I found in another page on gyromagnetic, the gyromagnetic ratio page on Wikipedia, that actually the electron field of an atom always processes at 28.025 gigahertz per Tesla. Doesn't matter which atom. The electrons always process at 28.025 gigahertz per Tesla. And it's the only difference is in the nucleus of the atom, that they all have different ratios of precession. And according to Alsa Phan, by orienting the electrons, you're able to orient the subatomic particles of the atom and basically shield the atom, the nucleus of the atom, or any matter, the spacecraft, from the effects of gravity, by making the entire craft oriented, with the same orientation, that their precessions are aligned in one point, and then you're able to travel along the axis of the orientation without any effects of inertial mass, along the axis and along the plane as well.
So yeah, pretty close. The key there is. Go ahead.
There are two different theories. I actually went down the same path as you. There was a time, and there's an earlier video on Alien Scientists, where I postulated that perhaps the gravitic field does come from the electrons, and in the way an electron coming closer to you is essentially an electric field, and moving farther away from you is a negative electric field. So when it spins around the atom, I thought maybe that spinning motion has something to do with a pulse that it creates in all directions of a high rise time and a low drop time of voltage, and that creates a small gravitic pulse which attracts everything together.
You're close, but the key here is to understand the energy is leaving the system. So nothing is truly entropic. There are a few asymmetries within space and time. When you have an electric charge like an electron moving around the nucleus of an atom, and it's
did you say the electron field is actually releasing a radiation of some sorts? As in
it's continuously radiation, but only because it's moving, and that's the big key to take away from this. The electron in its orbital band is releasing a magnetic field that's radiated outwards, and that radiated electric field, which is predominantly negative, and as we well know from relativity, if you accelerate an electron within a wire, as in you apply an electric current, 1 amp, 10 amps, whatever, into a conductive material, as the electrons flow through it, even though they're not moving very fast, the sheer number of electrons that are moving produces a magnetic flux. So yeah, you could say it's nothing but the end result of electrons moving around atoms. So here's the catch. If you take any molecule in existence in this universe, and it has electron that's present, that's moving in its valence band, it's got to transmit energy. That's the only way that any other atom or molecule nearby it can receive the information about its position and its charge or anything like that. That's basic chemistry 101. So the fact that we know any electric charge in motion produces a magnetic flux means that there has to be a dissipated energy. So all atoms dissipate energy. And now take a look at the bigger scope, the whole entire universe. An infinite number of individual electrons rotating around their valence bands of this stuff we call matter. Well, as these electrons move, they transmit energy, and they lose some. They transmit amount of power. I wouldn't say they lose some. That's actually an incorrect term, as I stated. But because they're not going to lose their electric charge, but the fact that they're in motion means that they transmit some electromagnetic flux. This one thing alone is the key to take away, because it means that as long as you have one electron and one proton anywhere in the universe, you're going to have gravity. Now, if you take these things and separate them, like the electron and the proton, you separate them apart, you have an electron sitting in stasis, you have a proton sitting in stasis. You're not going to have the same types of gravitational effects that you would if you had an atom where you have an electron and a proton at the very minimum. And this is because it's dissipating energy, and energy has to be equalized somewhere in the universe. So if you have a high concentration of energy in your one hydrogen atom and you have a low concentration of energy outside of that area where it's transmitting electromagnetic radiation, the area with the strongest energy is going to catalyze anything moving towards it or away from it with the highest density. Ultimately, anti-gravity, as far as I'm concerned in this context, would equal transmission of electromagnetic energy without an equivalent receiving of electromagnetic energy where you're losing your power just like any radio transmitter. And the fact that you're losing power means that something must come in to take its place, because as we know from the second law of thermodynamics, which is highly negotiable, in my opinion, if you lose power, you have to gain it from somewhere else in order to have the system reach equilibrium. The key here is that they don't have to reach equilibrium at the same exact time. You don't have to lose energy now and gain back energy now. You can lose energy now and gain back energy later. So yes, every atom does produce a gravitational field, but primarily if you take those molecules apart, they do have some sort of mass, but electrons yet to this day in 2019 don't have a rest mass. So you can pretty much calculate that they are moving fields, and you can derive quite a bit of energy from those moving fields if you have an ability to interact with them. But sorry, go ahead. Long drone there.
Yeah. To be honest with you, I had a similar theory a couple of months ago. I mean, I jump in between theories. I'm all about figuring out, seeing it in a lab, and since I haven't seen it in a lab work yet, I'm a little skeptical. But I'm all about different theories. We try them out in the lab to see if they actually work and see what happens. I'm just reading the chat here on our channel, talking about John Hutchinson closed down his YouTube channel or was taken down just recently. There's something about Joe Rogan recently too. And what else is going on? Somebody asks you a question: could electron movements generate a photonic vibration in matter, and this couple with the gravity field?
Absolutely, 100%. Let me answer that question. So if you take an electron from point A and you move it to point B very quickly, you'll have a very strong flux. If you take an electron from point A and you move it to point B very slowly, you'll have a weak magnetic flux. Why? Because every other electron and every other proton in the universe is already sent out that dissipated magnetic field, that radiated energy. So that energy is around us all the time, everywhere.
Let me ask you a question.
Go ahead.
Total energy, like you're going to raise the voltage in a millisecond and then release it in 10 milliseconds. But the total energy that is released or returned in the 10 milliseconds, is that less than or equal to the amount released in the 1 millisecond? Because you're going up and then you're going back down.
It's much less than, because in the first 1 millisecond you're transmitting most of your energy. In the next 10 milliseconds, you've already transmitted that out. You've radiated it, which is the correct term for any kind of antenna physics. You've radiated it out into space and time, so it's lost according to conventional physics. You've already dissipated it. Now on the return side, if you don't dissipate as much energy on the negative side of the slope as you do on the positive, you're going to end up with some kind of strange asymmetry, which for basic electrical engineering would equal you now have a voltage that didn't exist before. Let's say you take a sine wave that goes 50,000 volts positive, 50,000 volts negative, and it does that at 50,000 times a second. If your voltage goes positive to exactly the same amplitude, 50,000 volts, as it goes to the negative amplitude, 50,000 volts, you're going to end up with absolutely nothing at the end. But if you continuously increase your voltage in one direction or the other by dissipating the rest of that voltage as radiated energy, those electrons that are moving in your transmission antenna will lose momentum. They will accelerate, and because they're pushing against velocity c, or the speed of light, they're going to eventually reach the maximum speed where if you try to input more energy, it's going to be harder and harder and harder. So if you make electrons shift from position A to position B during one direction very fast and they move very quickly, they're going to dissipate energy in one direction to quite an extent. But if you didn't then move them back slowly in the other direction, they're not going to dissipate as much energy because the charges that designate how much energy you're transmitting are going to be moving much slower.
Okay,
And
so
because of this,
basically-
relativity doesn't take effect.
So basically, you're pushing against the ether using electron dissipation.
That is literally exactly correct.
Okay, so the ARV kind of makes sense now. So what we got in the core of the object is a matter, what do we call it?
Hold on, though. There's one more little catch. Let me just. I'm sorry to cut you off, but there's one more little catch. So the key with T.T. Brown stuff and what he ultimately figured out. Let's cut back to this. Is that momentum, inertia, and mass are variables, which is a hell of a thing to say, but they are in fact variables. You can change the inertia or mass or momentum of any given object provided that you supply external magnetic or electric field to orientate that material. So T.T. Brown, in his research, he discovered that there was quite the asymmetry between the mass of electrons and protons, and you can use this asymmetry to create a unidirectional single force, whereas you would normally be just imagine a speaker coil. Okay, you have a speaker that's moving in and out. If your speaker coil continuously moves outwards and never moves inwards, of course, with a speaker, it'd break its boundaries and tear out its own cone. But with electrostatics, you don't have any physical material. So if you continuously create a increasing positive charge, you're always going to have an electrostatic differential between your producing positive charge and any external objects. This differential electrostatically is the same as any two oppositely charged objects attracting to each other, but more so, you can call this gravity, because if you do this really, really quickly, we're talking, many petahertz for the rotation of the electron around its valence band. This electromagnetic field does in fact produce quite a bit of force, and if you concentrate that into an insulating material, a dielectric with a very high K factor, like
barium titanate,
titanium, any of the titanium oxides work real well. There's tons of ceramic materials this day and age to do it.
We have some barium titanate for that.
You got barium titanate? Nice.
Yeah.
We are going to have to talk about that, because I have some experiments that I can tell you how to set up specifically with barium titanate that will yield some very interesting results, I hope.
We'll try it out. I mean,
but yeah, if you want the asymmetry to create a continuous electrostatic charge of a single polarity, you got to dissipate the energy, and it all comes down to getting rid of the energy and getting it outside of the closed loop system, where you create an open loop, and now you're able to push against space and time itself.
That totally makes sense. It's sort of like, it's not fighting the second law of thermodynamics. Any motion tends to stay in motion, or to like a rocket, basically. What you're doing is you're taking electrons, creating a stream, pushing it into this capacitor. The energy from the capacitor dissipates in the form of an electromagnetic wave, and you move in the other direction, because you just took mass with these electrons and dissipated them outward. So you're sort of like a rocket in that instance. Is that correct?
You're exactly right. Instead of propellant, all you're doing is you're dissipating electromagnetic waves, which do have a very factual mass. Now, I know there's a lot of physics
and this
research
makes
that
a lot of sense.
No, you're exactly right. If we were to make a really, really simple analogy, just imagine that you take a piece of, like a notebook or a piece of cardboard or something, and you try to push it forward really quickly. You're gonna experience air resistance, and that air resistance is gonna slow down your motion of pushing forward, and you'll experience some kind of, counter force to that acceleration. It doesn't change when you reach the speed of light. When you have these very small particles and you try to push them faster and faster and faster and faster, eventually the mass that they gain becomes so substantial that it outweighs the amount of force that you are required to propel it. So you reach this critical cross point where you're generating more external transmitted flux than you are circulating flux within your tank circuit. And this is super critical to do in one single direction, because ultimately what you want to do is create a monopole. You need some source of high voltage electrostatic energy that continuously increases in its positive or negative orientation. So yeah, you're right. You're absolutely right.
So if you coupled a parallel plate capacitor gravitator device that is your primary propulsion, along with an Alsa Phan style inertial mass cancellation device, you theoretically can go faster than the speed of light. Because if you can got the entire craft weighing as much as a subatomic particle, we know that subatomic particles in some instances can move faster than the speed of light.
I think that's one interesting way to look at it, but more so I would say that your mass in your localized craft doesn't much change. What really does change is the ratio of your mass that's localized, where you're sitting in your spacecraft in the driver's seat, to the external localized mass that you should have. You can change that ratio, and you can decrease or increase your mass accordingly. And when you change that ratio, you can apply X amount of acceleration force. Let's say it's 10,000 newtons or whatever. You can experience significantly more acceleration for that same 10,000 newtons on any given comparative mass than you would otherwise be able to do if you orient the electric fields outside of that mass.
That's very, very, very interesting. The Alsa Phan theory is basically you're removing all the inertial mass from the craft, which kind of looks like what's going on in the center of the ARV, the Alien Reproduction Vehicle, which I think is what we should concentrate on, because the ARV was the first iteration of 1954 technology, actually making an anti-gravity craft that got us to Mars, at least. Mark McCandlish is not the guy you should really be talking to. It's his associate that actually saw the device. Mark McCandlish is just an illustrator that put together this illustration from what another guy saw. So, but the drawing, it's starting to make a lot of sense to me from what we're hearing about parallel plate capacitors and gravitators creating some sort of thruster, electron thruster device that will create, some form of thrust, but not enough to actually take the craft off the ground. Then you have a secondary system that makes the craft weightless through dynamic nuclear orientation. And the craft is now, almost weightless. It weighs as much as a couple subatomic particles at most. And then you power up the parallel plate capacitors.
Let's talk about the ARV. Let me give a little information on the ARV central column, which is what we were talking about earlier. So let's get into that. So the central column of the ARV is one of the more unique and less understood fields of research. From if we were to trust anything from Mark, we would know that the ARV has this column in the center that was described to him that he attempted to draw. In this column, we see a needle electrode at the very base. We see something that was described as a Tesla coil, but we're not really sure what it is. If it is a Tesla coil, then that's fantastic. We can all build it. If it's not, then so much for that theory. But
I think the coil around there is an electromagnetic coil that orients the electrons in the aluminum flywheel.
You're talking about the upper coil, though. You're talking about the upper coil that produces most of the flux. It's the one that's shown in the diagram. In the center of the column, we have something unique going on. We have an electron beam, if you will, but it's not necessarily made of just electrons. These are probably very heavy or dense materials that are being accelerated upwards from the base of the ARV towards the top. As this heavy material, my guess is it's probably mercury. I've got some TT Brown patents on a mercury generator that I will send you, alien scientist.
Oh, guys, I was talking, but they couldn't hear me. I had my volume turned down because But I'm right here. I'm still moderating, and sorry you guys couldn't hear some of the stuff I was saying.
No, that's perfectly all right. That's perfectly all right.
I think the center column of the craft actually has to do with the pulse mechanism for the parallel plate capacitor base.
I want to
Yeah,
talk
exactly.
I want to talk a little bit about what I think it could be too, because you were just talking about this whole idea that, you know, like on the external shell, like space time's being pushed around the craft, but it would have to be reciprocating, like, and coming back around, you know. And I think if it's channeled through that center column and then kind of warped around the craft, it could kind of work like in the same concept that the airflow of an airplane wing does when, you know, it goes on both sides, creating that gradient or differential on the front end of the craft versus the back end of the craft to propel it through space-time. I don't know. If you understand what I'm saying, it's like it's basically like the space-time's going around, it's being pushed around the outside on the long way around on the outside, but then coming back through the quick way through the middle of the craft, and then circulating around, you know, around.
What if
Like
space time is merely like a field of electrons that is everywhere?
You pretty much got it right.
And
space-time is the end result of all the electrons that have ever existed and never, up to this point, transmitting their radiated electromagnetic field. The fact that all these electrons are transmitting a continuous electromagnetic field means that they are saturating the localized space. There's so much energy there in localized space that if you attempt to measure it, you end up with a frequency so high that it's almost indiscernible. But that's a lack of our equipment. It's not a lack of the technology. It's not a lack of capability for what's potentially possible. It's just simply that our technology is not there yet. We don't have high enough speeds. If you continue to increase the speed from where we're at now, which is up into the 10 to 15 gigahertz range for switching speeds, into the terahertz range, beyond that, into the petahertz range, you end up with the ability to detect gravity directly. Right now, we're trying to attempt detecting gravity through mass alterations or slight shifts in geological position on our planet, but it's a far cry short of what we really need to do.
Really?
It is. I haven't quite figured out whether or not they're saying that antimatter is repelled from the local gravitational force or if it's attracted. I know there's a lot of theories out there, and I'm not quite sure which one they picked yet. I'd love to hear your thoughts on it, though. I have not, but I'm willing to be educated. That would be typical. So, go ahead.
Yeah, the other night I got together with Tom, my physics buddy, and we did some of the math regarding the Alsa Phan experiment. I know some people are asking about that. We have a signal generator that can put out 9 to 9.5 gigahertz. We have an antenna and and all the wiring and an amplifier. That is thanks to an investor that we found at AlienCon who's very familiar with with microwave frequencies and stuff like that. So he knew where to find the correct equipment and the wiring and everything. So we're very thankful to him. Carl Miller is his name. And we did some of the math about the Alsa Phan theory. First, we want to figure out how deep the skin depth of the 9.5 gigahertz would be on the aluminum sample, because there's no point in going below the skin depth. You don't want it thicker than that, because then you're not going to be affecting the entire sample. So after much calculations, we found it about 0.5 millimeter. So our sample needs to be about 1 millimeter thick. We also, using the Gauss meter that was donated by the GoFundMe page, thanks to the guys who donated there, we were able to realize that the magnets that we got, the permanent magnets, are not applicable to this application.
What do you think that is? Let me just ask a question.
The neodymium field gradient is too great. We can only work from 3212 Gauss to 3389, which is a pretty short range, and the flux in between two powerful neodymiums is intense. The area that has that range is on sub-millimeter. It's extremely small.
Is this an equipment limitation? I mean, like, do you need more? Is this a matter of needing more funding to get better equipment? Is it an equipment limitation, or what is it?
Yeah, it's a bit of an equipment limitation, but it's also the design. We're just taking two neodymiums and putting together. I think the correct way to do this is to use electromagnets, which allow you to control the field density. You have two electromagnets or one electromagnet. It needs to be a different design. What's going on here is not the way it's been done on the ARV, and it's just not applicable to this experiment. So we need to work on that. We need to figure out how to make a very laminar magnetic field, similar to what happens in an EPR machine. Alsa Phan's son, David Alsa Phan, wrote a book, and he wrote that the most expensive piece of equipment was the EPR machine, paramagnetic resonance, which is a chemistry department piece of equipment. It's basically two Magnus electromagnets, and they're able to control the magnetic field in between two of them to a very laminar, a very steady, a very constant magnetic field. And then you're able to hit that at the Lamore frequency, the precessional rate of the electrons, and flip the nucleus over and tell what kind of atom there's going on there. What we're trying to do is we're trying to pulse the object at the Lamore frequency of the electron, but pulse it on and off and orient the nucleus of the atom, by which reducing its inertial mass, allowing the parallel plate capacitor in the base, which provides a little bit of electron thrust, as we would call it, to propel the craft and move it in any which direction you want. Also,
because there's a couple of different versions of this machine here that I see, and all of them, it seems like size is the factor here for building a more steady magnetic field. It seems like the bigger, the larger that you can build this coil, that the more steady it's going to be at this middle point where you're doing the experiment.
So look at the ARV. You'll notice there's an electromagnetic coil around the entire craft, and that provides a very laminar field for the central column, where the aluminum flywheel is. You see that the red area around the craft, the electromagnetic coil. So if that created a DC, magnetic field, you could then be orienting the nuclei in the aluminum flywheel, and the craft will lose its inertial mass, at which point the parallel plate capacitor, the electron thrust, will allow you to move the craft around. Another interesting thing I heard is, this was from Gaia, so it's not an extremely reliable source, but they claim that there's these tall white alien beings from Alpha Centauri or something like that have very early stage anti-gravity devices, and apparently as they reach the speed of light, the mass of their bodies increases, and they have to take certain drugs to overcome that effect. because your heart's now pushing much denser blood, and all different things changing your body as your density increases. I don't know. It doesn't really make so much sense to me, because where's that extra density coming from? Where's the energy coming from that does that?
No,
Yeah,
because everything we've seen is that information's conveyed through a field, and that if you're breaking that barrier, you're turning off your inertial mass, creating a bubble around yourself that kind of shields you from these effects. It's from what I've seen. So I don't know if I believe that. But back to like the reality of building one of these. This whole thing looks like you see this larger square coil. That's a larger coil on the outside that provides the static magnetic field. That's going to be your steady state one, and then these two other ones in the middle look like the counter axis magnetic field that pulses it to do the spin alignment. You know what I mean?
The spin alignment comes from an external RF field. You're not pulsing the magnetic field.
Well, in the Alsa Phan experiment,
he's right. It is DC. You have to have an external magnetic field to set up the effect. You need to cause some kind of orientation, and what you're going to do is attempt to saturate the orientation in order to increase the effect. But you do need to have something that's already present in order to cause those individual spins to orient in one direction or the other.
Yeah, but that's like in the diagram it shows. I don't have it in front of me, but for the diagram it showed for the setup for the experiment, it had this one static coil, and then it had this other one, these two round coils, as kind of shown. It showed like a similar setup in the Alsa Phan experiment paper. So
I should probably pull it up now so I can look at that with you.
Let me find it.
Basically, you had one field controlling the microwave source. You can pulse the microwave source. We don't need that because we already have a signal generator that is capable of pulsing the electromagnetic field. I kind of wonder what they use that for. And on the other hand, he has an electromagnet around the sample that creates the north and south pole. So, atom detector, lock-in amplifier. I'm not really sure.
Yeah, so our setup, we had two permanent magnets providing the north and south pole, but like in this setup, it would be probably this large square magnet around the perimeter, providing that first standard magnetic field, which would orient it, in this direction. And then these two white ones in the middle, which would spin it, align it in this direction momentarily, and then it would precess back to alignment with the axial of the square magnet, according to that Lamore precession. You know what I mean?
And the Lamore precession, once again, is constant across all materials. It's 28.025 gigahertz per Tesla. So we're going to be running between like 0212 Gauss and 0349 Gauss in order to work with our 9 to 9.5 gigahertz signal generator. But this is possible. You can do this at a lower Gauss and a lower gigahertz rate. Something's interesting. There actually was a flying saucer that came really close to one of those spy aircraft that the government has that has a powerful sonar, and it was reading 2.95 gigahertz pulses coming off the UFO, and it was pulsing them every 6 milliseconds. So if you had a constant magnetic field around the craft, that was on the order of like 1,000 Gauss, and you were pulsing it with powerful this is pretty much microwave energy, accurate, clean microwave energy, not like you have in the kitchen. That's not clean energy. If you had it pulsing with clean microwave energy, orienting the nuclei of the atom, the same effect would work. We're just copying the experiment as it's written first, and then we'll go on to changing the Gauss and the gigahertz rate, to more better fit any craft that we build. We wouldn't necessarily be using the exact frequency and Lamore precession in any craft that we were to build. This is just to prove that the concept works.
Right. I think we should start with like a small drone remote controlled, remotely piloted craft to begin with for test flights.
Amen to that, man. I'm right there on board with you. The whole goal of, and I've already told this, but I'll tell it to you too, alien scientists. We're working on micro circuits, something that really shrinks down the technology. And so currently our primary subject of research is figuring out how we can make this stuff small enough to be portable and powered off a battery. That's where most of the energy is going. So we've got already 300 grams levitating, and that's not all too bad of a mass, but it's still a far cry short of where we want to be. So minus these 300 grams, we have a long ways to go in our research, and it comes down to equipment. We just don't have the gear.
Like, if there's any millionaires out there that want to become billionaires, you know, we have the path to it. Or even billionaires that want to become trillionaires, because this field is bigger than anything you've ever seen in your life. I mean,
it's not about the money at this point. It's about, like, I really think it's, especially with the open source, because it's a lot of the venture capitalists and the money people that we've talked to. Mark, you know this from our private discussions, and it's stuff we can't talk about really because it involves people. But there's the people that want to fund this, they want return on investment, and in order to do that, they don't want open source. They want to be able to control they want to patent it, and they want to try to get it. And that's how, like, all these other companies have been shut down and bought out.
My response to that is that, listen, you're gonna help us out. We'll open source the concept.
The whole idea is that the big money is in asteroid mining. That's what I try to sell.
It's an application. It's an
applications. Once we get out there and
actually taking a rig and taking it to a craft and taking on Boeing and SpaceX, because I mean, literally, SpaceX and Boeing are out of business the second we start putting anti-gravity craft on the market. Who's going to go pay for an airplane, you know, billions of dollars, when you can get this little craft over here that runs on, you know, hydrogen fuel, and it'll take you to Mars in a couple minutes? Like, what the fuck? What are you doing with an airplane for? It makes me so sad.
If you really want to delve into the technology, you don't really even need the fuel, and that's the real catch of it. The asymmetry provides the power.
The whole thing that the powers that be are worried about is that you know, people like you know, North Korea could get a hold of this technology and use it to, like, transport an atomic bomb, you know, that's at warp speed. You know, right?
But you know what? They can do that anyways. You know, there's no more secret.
I agree.
If there's any scientist in North Korea that's really dedicated to anti-gravity, he could find out exactly what we found out, and he can do the same research we've done. He can come to the same conclusions. This isn't secret stuff. You know, I've only been working on this for like a year or two, and I already, like, you know, been down the rabbit hole pretty deep. And this is just a hobby for me. I hope this will become a full-time job. I really hope to God that I can, you know, stop whatever I'm doing and put my full time on anti-gravity, because it is a bigger industry than anything you've ever seen in your life. This is bigger than Apple. This is bigger than Microsoft. This is bigger than any atomic thing. This is the biggest opportunity for any investor out there to get their hands on this type of technology and help us build anti-gravity. And not just that, if you're a billionaire out there, just the posterity of actually.
Oh, we got billionaires, and the 70 people watching, how many of them are billionaires, you would imagine?
Well, who knows? Maybe they know somebody who knows somebody, but you know, thousands of people are going to watch this video, and if we could get somebody out there that can really help us monetarily, that would be great. Again, if you have any great ideas, that's also just as valuable, because we find that ideas are just as valuable as money many times. So any way that you can help out, make anti-gravity real, really, you know, reach out to us.
I think it's gonna be more. We got enough people, I think, so far to really start the initial things. It's just about I think we gotta continue hooking up with that media production company to get, like, high quality media put out. with the experiments, like one at a time, wanting to focus on knocking one experiment down at a time, and really publishing our results, and making it entertaining for people too, because it seems to be like a big part of the whole deal. But I really want to
No,
keep
it's critical. You got to keep people's attention, otherwise they're not gonna
I know
not
it
gonna give
seems
their attention.
it's an unfortunate side effect. It's like I want to focus on the science and the information, but like at the same time, I understand that production is a huge part of reaching a bigger audience with this information. And yeah, this is really cool what's going on. And Jeremiah, why don't you talk about like your lab setup and any kind of experiments that you've kind of done and stuff.
All right. Yeah. Well, my main focus is high voltage in the general sense. So we've got plenty of voltage multipliers that exceed 100 kilovolts and all kinds of impulse sources. But right now, the main challenge is creating fast enough voltages where we can dissipate the energy to create an asymmetry. And creating these fast voltage sources is a real challenge. Simplest way I can put it. It's a real challenge.
Let's plug your YouTube channel again for the people that just logged on or just logging in. What was the
Yeah, if you guys want to check out what we've done in the past, it's not anti-gravity related. I apologize ahead of time, but you can learn about high voltage circuits. We are Join the Technicians on YouTube. So yeah, if you want to take a look at that channel, we'll be posting more stuff pretty soon here, primarily as a result of this conversation.
Yeah, man, I look forward to that, and I'm sure a lot of other people look forward to that, and we're welcome to have you on board with us here at Falcon Space and Hover Brothers. We're expanding our network here, as we've said and we've talked about. We're trying to reach out to more and more people, including people who are kind of in the know but not so willing to talk about stuff, to share information that they might have with us any way they can. Like I said, we're going to be reaching out. I want to kind of set up a I think that Connecticut or New York would be a good local like congregation spot, but I want to set up like a conference or some kind of like meetup, where we could all.
Yeah, New York sounds good to me.
I would love to meet up in person, like all of us, to like have a think tank to sit down and this place is in Norwalk. It's very close to New York, so it's only like an hour drive out of New York, and right in Connecticut. It's right near the Maritime Aquarium. So this place is a really cool spot. We're gonna maybe we could find somewhere around there we could get like a meeting going on, and get a bunch of people together and even do like some interviews and filming and stuff for like a whole weekend of that. That would be real cool, to kind of kickstart the show.
Extremely cool. I'm totally down for that. I would love to talk to people about this.
Yeah, 2020 I'm thinking is going to be an eye-opening year for people, and I'm thinking like before we kick off the year, maybe in New Year's, maybe in January, I got to find a good date, like we can all like we can set up a good time, like for a conference or something, that we can get people who are like-minded to come down, and hopefully people who are out there can show up, or just have a spot that they can come and drop off information, or have someone they know like come and drop off a package or information. There'll be anything we can get to guide us in the next year of research that we're going to be doing and stuff into this. But yeah, I want to set up something like an event that people can all come together and meet up here on the East Coast, and bring like-minded individuals together to set up what's going to be the start of a whole series of experiments and collaboration on experiments and stuff. We're going to kind of sketch out a whole idea for what we're going to do and how we're going to approach this, and also identify key individuals within the infrastructure, people who can provide consulting and materials and different things.
I totally agree. I don't. Eric Dollard, for example, has done plenty of this kind of stuff through Aaron M, and it's turned out pretty well. So I would say we were definitely on board with trying to expand this research to anybody who's interested at all.
Yeah, I'm gonna have to start talking with Mark and plan this out a little bit better. But we're gonna probably have an event sometime before February of 2020, anyways. Where we can get some people and some minds together, maybe around Christmas time, because that's when a lot of people are coming back to this part of the country and will be in this area. A lot of people travel during that time, so it might be a good time to do it in December or something. But I got to.
I agree. It's coming up quick, and we have a pretty limited amount of time to educate
I think
people
we should
on what we have going on.
We should almost start doing like an event every monthly event, just to get like people who can't make it to one will be able to make it to another, and just have like a monthly like meeting of the minds where we discuss everything, and then we go back to our labs, and, because everyone has their own labs and stuff, and not everyone can attend the physical meeting, but we'll have Skype in conferences with some of our main collaborators and stuff. But the whole idea is I want to get interest involved and bring people on board that wouldn't ordinarily feel comfortable stepping out of their environment and have a space where they can come together. So maybe it'll be maybe we'll do a tour where we do like a monthly event. We'll have one up in Boston, have one down in Providence, have one in down in New York even. We'll work our way down the East Coast, and then maybe start doing some next year once we get funding and some more stuff, infrastructure together, start doing them on the West Coast and in other parts of the country as well, to get more people together. But I think we got a good I have a good feeling that we're going to reach out to the right kind of people, just being in the area that I'm at. I lived in Boston for a number of years, and there's 50 colleges within 50 square miles, and you have MIT and Harvard, two of the top physics schools in the country, where some of the best physics minds in the world go to study these subjects, and it's a great.
They're not studying these subjects. They're studying basic physics.
Not necessarily, but MIT has a particularly unique spot on the academic market, and
it's got people
they have dedicated laboratories. They have people that are almost 100% of the time working in these laboratories. They have the equipment, they have the funding, and they've got a pseudo free reign investigatory type of perspective, where anybody that happens to be part of that crew, they can get access to the lab equipment. If you're already a student there at MIT, you have access to the lab equipment. You're probably in courses that you can do it with. They have an incredible amount of gear, just sheer gear, and we can utilize that to our best advantage.
Yeah, they have tons of gear, and they have equipment to do any experiment we could ever possibly imagine, and funding. So yeah, they'd be an invaluable resource if we can find the right people there at these institutes, and also some of the people that have reached out from NASA. I'm going to start trying to reach back out to some of those people too, because I've had some interested people reach out from NASA as well. And you can't just have that pessimistic mindset that these people are, oh, they're all bad and they work for they're the government trying to infiltrate us. And as long as we're open source and we're dedicated to performing a wide range of experiments and trying to realistically interpret that data and report accurately on the results, I don't think we're gonna have any problem with disinformation agents trying to mix and meddle in the mix, because they're going to be sorted out very quickly.
Actually, the people down in Huntsville, one of the members of that team worked on the Podkletnov experiment with NASA, and there always is that criticism that the disk was not large enough, and he's one of the believers in that they haven't really given that theory justice, and very interested in retrying it with a larger diameter.
Well, it's interesting, I hope that I've contributed to that kind of debate as well, because that's what a lot of people that I've talked to have said, and about the initial replications that were done at NASA's Advanced Research Labs by Whit Brantley, I think was the original researcher that did the. He's dead now, I think. Yeah, Whit Brantley. He's dead now. He died of, like, I think in 2017. I remember talking about that when he passed away. But Whit Brantley did the original replications, and he used a really small diameter superconductor disk for that replication. Yeah, here he is, L. Whit Brantley, and. Yeah, so there's people there that have definitely worked on this at NASA's Advanced Concepts Office, and the research is there and it's ongoing, because there's people that want anti-gravity, they want real anti-gravity, and that's one of the arguments I've had against some of your beliefs, Mark, is that if it was this really low-hanging fruit, then why haven't these guys figured it out, and if it is, it would be that easy to sweep it under the rug.
Oh, it's not. I mean, creating the types of fields that you need, understanding the physics behind it, it's certainly not an entry-level physics course. You're not going to learn this in 101. If you really want to get deep into it, the only way is to start doing your own research, because you're not going to find this stuff in college textbooks. You're not going to find Maxwell's original 24+ equations in college textbooks. You're going to have to look them up outside of that whole academia genre, and the information is available. It's there. You just have to do the extra work to get your hands on it.
Yeah, there's quite a bit of work out there, and I barely have the time to do any of it, man. It sucks. I'm so busy doing my regular day job, and this is like my hobby. But it's what keeps me up, man. It's what keeps me going. It's like I think about it all day at work, and unfortunately, I can't listen to any podcasts that talk about this stuff, because we're like one of the only people like talking about this kind of stuff. It's like I want to like be able to turn on a podcast and listen to like some scientists like unload about all this kind of stuff that I'm really interested in, and that really like is the real stuff, but it doesn't exist. You know what I mean?
Yep. Listen to your own podcast.
I know it's I can only listen to myself so much, because it's like what I listen to all day inside my own head. But we need to get more scientists, and it was great getting Jeremiah here to join us tonight and share his insights and inputs as well, because it's great to get more minds like that on board, and I want to reach out to more people like this, and I know I've talked to many of you, and we've probably spoken, but let's jump on a podcast and actually like get out there, and like we did. We didn't jump right into the podcast. We were sitting here shooting the shit for like an hour beforehand before we went live with it. But let's, like, I want more people out there. I know some of you are listening even tonight, or will watch this in the upcoming days, to think about, when you're ready. Not everyone's ready to get out there and share information out there freely like this. But if you're not, and like let's just stay tuned, and like when we put these events together in the upcoming months, this is going to be key to draw some of these minds together and get the right kind of team built for what needs to happen in 2020 for true disclosure and vision to be reached within the community. Because all these people hoping for disclosure are trying to push like, who's really doing anything out there to push the ball forward, and it's really going to be
a surprisingly lack of people really putting themselves out there in order to take the risk that's necessary. You have to be willing to say some stuff that maybe you're not entirely sure of, but you've got to educate people anyways on what you already know, because this is a hard area of research.
This is the cutting edge. It's the cutting edge of physics and science and technology, and I think that it's really important for people like us to be doing what we're doing and trying to build a team and move this ball forward,
Hey, you're
regardless.
absolutely right. There's one thing I would say though, and that is, a willingness to be wrong.
Mm-hmm.
I think when it comes down to the end of the day, you're going to ultimately be faced against incredible opposition, lots of misinformation. You're going to be facing people who have had their hard thoughts and are really fixated on it for a very long time. And you're going to have to weed through all that stuff if you really want to get down to what works. But I think we have a bit of an advantage in this category, and that is we all universally recognize that the only thing which matters at the end of the day is whether or not your experiments can prove your hypothesis. And if you can't perform experiments, then unfortunately there's not really a whole lot to convey. But if you can perform experiments, if you have any kind of a setup, or if you have the ability to fund a setup from somebody else who's already doing one, and all three of us on this podcast are definitely talking about that. That's where the energy is going to go and create something real and tangible, because we need the funding, we need the technology, we need the components, and we know what we need. We just simply have to be able to buy the stuff.
Yeah, it's really an issue of like I can only do so much with my day job and all the stuff I have, all my obligations in life and family I support and everything. So, but there's people out there that want this technology, that want cool toys, that want flying saucers, that have the money to invest in this kind of stuff, and they really need to. It needs to be about bringing this kind of this collaborative effort together. But those people will come, and I don't want to just sit there and talk about reaching out to billionaires that aren't in this immediate audience, because we just got to keep focusing on the research and doing what we're doing, and those people it's going to attract that kind of attention when it needs to, and once we get results and stuff put out there,
Yeah, I mean, the baby boomers were promised flying cars. That's the generation where all that tech really came out. You got early cartoons, the Jetsons and whatnot, flying cars everywhere. Everybody has anti-gravity in the early generations between the 50s and the 70s, and then it just sort of disappeared from popular interest. But there are a great many number of people who are very willing to exert their time to at least look into it.
Jeremiah,
We were promised something that we can't have.
Consider this. We're probably the only planet in the cosmos that has internal combustion engine vehicles running with GPS systems.
What a crazy concept.
Isn't that crazy? We have internal combustion engines to run our vehicles.
Let's plant a bunch of old trees so that we can achieve some slight mediocre approximation of efficiency.
It's just literally insane. This technology has been out there. We've had it since 1954. In my opinion, it's a crime against humanity that it has been withheld for so long. And it's a crime against science that, the science has been withheld as well. Because you go to MIT professors, they're so close-minded, they can't even, profess to believe that such a thing is possible.
Well, to some extent. I mean, MIT professors, if you're going to go to any single university in the entire United States, MIT would probably be a really good place to start. And I believe that, as far as I've researched MIT, from quantum dots with LEDs, which are now known as phosphorus conjugatives, you have these technologies that have come out which are quite extraordinary. LED technology alone is just one of those fine examples where you have people from academia, which, contrary to popular belief amongst the alternative community, that's us. These guys are actually doing some real, genuinely good research. They're smart folks, but they need direction and they need something to work towards. They're motivated folks like us who want to achieve something special for themselves, because I think every human being born on this planet wants to achieve something at least unique for their own life, for their own existence. They want to work on something that seems like it's worth their time and their investment.
Mm-hmm.
And in this field, it's definitely very viable. There's so much research that's already been done, and unfortunately, you're not going to find it in your textbooks. But you will find it online. You will find it in independent research. You will find it in the lab notes of the people who have done a ton of research on this stuff. There is so very much information to go off of here. But ultimately, at the end of the day, what it really equals is people who don't have the time but maybe have the money, they could fund this. People who have the money but don't have the time, they've already got their stuff set out. Us independent researchers, people like myself, we're investing our time because it's our most valuable resource and we have it. We're putting our energy and effort and our very soul into doing this research. It's not something that just us, just all of us three in this conversation can do. Anybody can go out and try these experiments, but ultimately, if you don't want to personally set up a laboratory, if you don't want to buy the high voltage power supplies, the semiconductors, the components, if you don't want to get yourself educated in engineering, I mean, there is a way that can really help bring this technology to the forefront of what we're talking about here, and that is by funding it, because obviously everything that we have here, we're doing this independently. We don't have a big lab. We don't have government funding. We don't have MIT's resources. We don't have any of this stuff. We're just a couple of guys that are trying to figure out how the universe around us works. And we're so willing to share that. All of the information that we learn with you, all we need is a little bit of funding.
Yep, and with thankful for the people that have gave me donations. A couple people donated through PayPal on my alienscientist.com site. I got about $200 in the past couple months, and I used that to pay for some website work. I'm trying to redesign and redo my website, update it, because all this information that's coming out and everything that's happening. It just really needs an updated news source where I can put news articles and keep things updated with everything that's happening and all the developments and all the new stuff I'm finding that's even older stuff that's been just like hidden in plain sight for 10 years, and now I'm just finding it and putting all these pieces together, because it's really an amazing time, everything that's going on. But I also, all the people that donated to our GoFundMe page.
Yes, kudos to them. Thank you. Got a
100%.
We got a magnetometer off of that, and like every little piece of equipment that we get off of the GoFundMe page, we always post it and show you exactly what we're using the money for. Every penny is well spent, and a big thank you to everybody who's helped out over there. We are working on a shoestring budget, and helping out is amazing. I believe that this is a crime against humanity, that this information is being withheld, and we're trying to bring disclosure through technology. Like, once we show you a flying saucer and how it works and explain the technology, give you the schematics, go build it in your own lab, at that point, there's nothing to hide anymore. The whole reason why they're hiding aliens is because of the technology. They're afraid the technology is going to get out, and they won't have, a hegemony over it anymore.
That's the whole big stigma surrounding UFOs and the whole alien thing. The whole conspiracy is that it's all about hiding this technology, because they know once this cat's out of the bag, there's no putting it back in.
Exactly. There's no way to hide this stuff. To the Stars Academy is pretty much trying to softly nudge us in the direction of disclosure, but not give us the technology. We're all about technology first, then you get disclosure. Because once you have the technology, I mean, you can't disclose the 787 Dreamliner because people have flown on it. There's no there's nothing hidden at that point. So good technology is the correct method for disclosing this stuff. We've been at AlienCon. just handing out the information free of charge to
I
everybody.
know, and look at To the Stars Academy. Their minimum investment is now $350, so that's minimum. Most of our investments have been under $350, and we've done way more to advance the science in the past 2 years and like really publish the information than these guys have. In fact, they just took that video down, man. I was just talking about that earlier. The one thing that was like real Hal put off really releasing some real information. The one time he actually talked about some real stuff, and it's been taken down, and like, you know, now they're back to, you know, pushing that Tic Tac video, and I don't know who knows what, but it's just it's kind of ridiculous, man. Like that these guys are out there raising all kinds of money and promoting and getting all kinds of attention for
It's
what?
crazy, dude. I remember Dr. Schindler's research. Schindler was a very interesting fella, but yeah, he suffered the same kind of fate. YouTube channel, public presence, Facebook page, all disappeared right before our eyes, and then the guy was gone. Now, luckily, enough people have duplicated his work and reposted his videos to still have something there, but Schindler talks about the ground current, and it's all very much related to this idea that you can create a greater amount of output that you can create than it takes to create that input. So Schindler, he's another interesting fella. That's something that we can talk about later. But yeah, his videos have just finally come back up on YouTube. They've been out for a while, and now they're back up online, and you can find them.
Yeah, I mean, in perpetual motion machines and, you know, tapping the 0 point energy has been the discussion of many ufologists. Steve Greer is very into that. He's into talking about it, but I haven't seen a single picture of any tangible technology.
I've not seen anything from Greer that would indicate he has a conceptual working knowledge of the technology. It sounds to me like, and I'm not trying to rip on the guy here, but it sounds to me like he has a very summarized version of what's going on.
You should hear what Linda Moulton Howe had to say about him. He's you know, she said she didn't want to say it, but she's like, he's a real asshole. He's all about himself. Somebody just donated, actually. Brian Poe donated a Falcon space program on GoFundMe. Thank you very much.
Wow, thanks, Brian.
Nice, dude. We're getting some stuff going already, man. This is great. Arnie and Benjamin, they helped us get the magnetometer. Special shout out to them. Thank you guys. It's always, you know, if you don't want to have your name by, you can always donate anonymously. I also have a Bitcoin dump. I think somewhere I can post that. Let me find a way people to donate to me through Bitcoin.
Anything you can do to help is very helpful. You guys are going to be part of something really bigger than yourself, bigger than you can think of. I mean, there's going to be
tremendously helpful. We can't even emphasize enough just how much a tiny bit of funding goes. It goes a long ways.
Oh my God, Glenn Gaston.
We're wasting nothing. We are absolutely nothing. We're putting it all directly back into research.
I put everything out there, man. I'm all open. I'm all about open source and just sharing information. I've put 10 years of my own personal time and research into this, and I've shared every single bit of it without ever really asking for money or demanding money or putting anything behind a paywall like some other people do. Everything's been free of charge, and I've always just been dedicated to just the information and getting it out there. People, I want them to know that I'm not in this for the money. I'm not in this to sell anything. I'm just I'm in this to help people out, and I'm hooked up with the right group of people now that we're doing good research, and we're putting this money and all these funding to good use, and can't wait.
A guy named Glenn Gaston just donated as well. Thank you to him as well.
This is awesome. This is why I need to get my monetization back with the super chats too on my channel, so that we can start doing the super chats and getting people to ask questions and bringing stuff to the forefront, because I'm seeing a lot of stuff that people are talking about, but I try to pay attention to the chat feed, but it'll be a lot easier if people were like, oh, here's $50, and can you answer my question about this and this, and I'd be like, hell yeah, it'll be a lot easier. But
Oh, by the way, folks, if you're interested in doing this kind of research yourself, let's say you're like us, you don't have a lot of money, you're on a limited budget, and you're trying to do this research, we're very extremely extraordinarily interested in hearing about what you might have discovered in your research. I mean, feel free to contact us, and I'll let you both of you do that. You can contact us on our Facebook page at Join the Technicians. So other than that, though, there are many medias to interact with us. And if you want to check out Join the Technicians, you can talk to me personally. If you want to talk to alien scientists, if you want to go into any other avenues, there are other ways to do this. I'll let you guys talk about how they can get in contact with you. If they have information, if they like you personally and they want to share something with you, please feel free to tell people how they can get a hold of you.
Yeah, and if you think you're from another planet or something like that and you're living here on Earth and you know how these things work and you don't have any money, just give us a call. We'll take that information and make it real.
That's exactly right.
The only difference between us and aliens is the technology. That's really what it comes down to. The reason why I'm so focused on this is I have a background in Hebrew biblical studies, and I spent up until the age of 20 literally learning the Bible, and then I took a step back and realized the entire thing was all about aliens. Aliens coming and splitting the sea and leading the Jews out of Egypt. All those miracles were actually just advanced technology. The pillar of fire and smoke they saw in the desert was really a spaceship that looked like a pillar of fire and smoke. And the entire Bible suddenly made sense, and I was like, fuck, they fooled us so bad into thinking they're God. We got to figure out how they did that. And, because once we have the technology, there's nothing stopping us going to another planet and fooling them into thinking we're God, which I would never recommend doing. It's a bad idea. Don't do that. It violates the prime directive, which is there for a reason, for a spiritual reason. It's there. Don't go ahead and do that. But that's what's been done to us, and it's really fucking annoying, and I want to figure out how they did it. Oh, and Norman Somerville just donated to our GoFundMe page. Thank you very much, Norman.
Nice, dude. Hey, this is awesome, and I'm glad we're doing this. More stuff is happening than ever before, and if we get this conference set up and a bunch more people together, I'm gonna work on that flyer and getting that posted up this week too at MIT, and really get this this group growing and going. And the more people that contact us and reach out, email me through my thealienscientist@gmail.com. I'm gonna have another. I'm gonna try to set up a more secure personal communication too, where people can mail stuff or send me stuff personally. That would, in addition to these conferences where people can show up and give me stuff, because we're trying to get as much information together, and really the experiments is where it needs to be at, though.
If you guys want to see something like at a live conference, if you want to show up to any one of these events and you'd like to see something that's tangible, replicatable, duplicatable, this is the way to do it.
Yeah, if you got something you can show off and you want to release it, this would be the place and the way to do it through this group of people. That's what I want to create a collective that's dedicated to scientific disclosure and discovery through experiment. But anyways, I'm getting tired. It's 1:30 a.m. here, and I'm ready to wrap this stream up for the night. And I think we've got our
we have our goals in order, and we know what we need. We just need a little bit of external assistance.
Yeah, stimulation to the equation. So we're setting it up. We have a lot of potential energy. We need more kinetic energy. So
Nicely said.
All right, guys, thanks for watching, and thanks again to our guests, Jeremy and Mark, are my two lab partners here at Falcon Space, for joining me. And let's don't hang up, guys. We're going to keep the conversation going. Anyone that wants to join us, hit me up on Skype. I'm Alien Scientist on Skype, if you guys want to find me. And look for Jeremy the Alien Scientist. And you can join our little, we're going to be, hanging out for at least another half hour or so before I go to bed, and talking about some stuff on Skype. So if you want to join our private discussion, please feel free. Thanks for watching, guys, and hit us up, and let's get...
The email for Falcon Space is falconspaceprogram@gmail.com. You can also check out our YouTube channel, Falcon Space Program on YouTube. We have, complete unedited videos there on our YouTube channel, and you can watch all the experiments as they happened. And every time we found something that created a false positive, we went and corrected it. So you can see the progress of the experimentation in the lab as it happened on the Falcon Space Program YouTube channel. Make sure to like and subscribe, and hit that bell so you get every update. The Alien Scientist channel right now has the most viewers and stuff, so we're using that as our primary advertising and media outlet. That's what's happening at Falcon Space. We're also going to come out with a series of videos similar to Mythbusters. I was hoping it would be similar to Mythbusters, that we start off with a theory on anti-gravity and try it in the lab and see if it works or not. And each episode will be concentrated on one theory, go through how we actually built the stuff, and until we figure out actually how it's done. Hopefully we'll bring in the people that are all interested in this stuff and team together and get us to the stars.
Yeah, and once again, join the technicians on Facebook. Join the technicians. We will be glad to answer your questions. If you have something specific about anti-gravity, just send us a message on Join the Technicians on Facebook, titled Anti-Gravity, and we will get back to you on this exact topic.
Heck yeah, guys.
Very, very interested in hearing your experiments, your technology, any questions that you have. If you want to know about the engineering side of it, specifically the how we make this practical and real, that's where you want to contact Join the Technicians.
Yeah, let's do this. Get connected, guys, and we're gonna be doing this, regardless of whatever David Fravor and Joe Rogan are doing. We're gonna be working in the lab and building real anti-gravity technology. Will these people talk about, videos.
Lights in the sky. Lights in the sky. That's literally all they offer you, is lights in the sky.
As you would say, nice attempt, bro, but not there.
More of the same. Been hearing that stuff for 50 years now. So time for something.
Much older than lights in the sky goes back to biblical times.
Time for something new.
Part of history is lights in the sky.
And now for something completely different. Alright, guys, thanks for watching, and have a good night. This is Alien Scientists, and I am out, ending the stream. Stay tuned next week for more updates.